All right, we're preparing to live stream. All right, everyone. Welcome to meetup number 161. Please bear with us if there's any delays, because I'm the only one running this now, and this is my first time organizing the AV side of things. So we do have a couple of initial requirements. If there is an emergency, there is an exit over that side, so hopefully we won't need to use that. If you need to leave at all, you'll need to press the green button and then exit out. Just give a knock if you're coming back. Toilets are outside. I think that's the initial things. If you need anything after I'm off, you can come and speak to me, or Hazra up the back there. All right, let's kick off because we are running a little over. I'd like to start with acknowledging the traditional custodians of the land on which we meet here, the Wurundjeri, Woi Wurrung and Bunurong peoples of the Kulin Nation. We pay our respects to their elders past, present and emerging, and recognise their ongoing connection to the land, and we extend that respect to Aboriginal and Torres Strait Islander peoples either here today or watching online, wherever they may be. We operate via a code of conduct. The short version is there. The shorter version is try and be nice to each other. The full code of conduct is at that URL. That URL also has an anonymous feedback if you want to feedback anonymously, or you can come and speak to myself at any stage if you think there's something that needs to be acted upon. We are on the web at various places. Our website is the top one, melb.awsug.org.au. We are on LinkedIn and on YouTube. So we generally stream these. If you're watching on the stream, you know where it is. You're in the audience and can't make another session but want to watch, that's it. And you can always go back and see any previous or upcoming meetups. All right, we start off with introductions, which is what I'm doing now. We'll go through the What's New segment. And then we've got two speakers tonight. We have Dale and Steve Sennett coming up and presenting on implementing IAC. And then we have Pinaki talking about extending the DevOps agents with custom MCP servers. So two good talks, high-level one and a more in-depth one. Then we finish off with Marketplace. The way we do that is we go for a who's hiring. So if you're looking for people, stick your hand up and we'll bring a mic around to you. We generally don't do a who's looking for work because if your boss is watching on the live stream, there might be questions tomorrow. And then we try and close about 8 o'clock. If you want to ask any questions for those that are watching on the live stream, you can either do so on our Slack in the #Melbourne channel, or you can post your questions in the YouTube chat. We'd like to thank our gold sponsor, Mantel Group, and our silver sponsor, Civo, and our venue sponsor, NAB. Without them, we either won't be able to have a place for you to meet or provide the food and drinks. So we thank them a lot. As I said, we've got the Slack channel there, so you can find out all the information from our website /Slack and join up. We have various channels there. So we also have a jobs channel. So again, if you're looking for people, you can post there. If you're wanting to look for work, you can also post there and hope if you're currently employed, your boss doesn't see. There's various ways that you can get involved. One of the big things, we almost always looking for speakers. We are a community group and we get people from the community to come and speak. If we don't have speakers, this event gets pretty quick and boring. We're also looking for sponsors. If you're interested in sponsoring, reach out to us on Slack, and Matt, who looks after that side of things, will get in touch with you. And if you want to help out with any of the setups or the things that we do, we have a volunteer channel on our Slack. So go and say hi there, and we'd love to talk to you. All right, we're not the only show in town. There's a little thing coming up at the end of the year called reInvent. It's in Las Vegas. This is AWS's big yearly event. It's massive. Last year there were about 60,000 people. It's amazing. It's crazy. Really good. If you get a chance at some stage in your life, highly recommend it. But it's not cheap. So it costs about $2,500 for the ticket, plus flights and accommodation. But it's worth it. A lot closer to home and a lot cheaper. On the 16th of October is AWS Community Day Australia. As the name suggests, this is put on by the community. So user group leaders and community builders from around Australia putting this together. So we have assistance from AWS, but they aren't running it. It's again, like this meetup, put on by the community for the community. So tickets are there. They're like $20 for a head. There's the call for papers up until the 16th of August. So, but yeah, again, because it's a community thing, we can't sort of pay for anyone to come up. But if you're wanting to go and make your way up, yeah, and you'd like to try and speak, put in a paper submission. But it is a great day. It's on a Friday, so take a weekend and enjoy Bris Vegas for a weekend. Other things, we have the Women in Cloud coming up. It's going to be an online one on the 11th of August. 5 lightning talks on various topics. Got the QR code there. Also, too, you can post up in Slack if you miss any of these, or check it out on YouTube. Go back and grab the QR code from there. Back one. And Melbourne Well Architected is on the 19th of August. That's at the AWS offices. And there's text there. So next part is the What's New section. So for Melbourne, we've got a couple of new instances that have come in, the M8 GD. So just new version of instances with some large drives there, and the associated RDS and Aurora versions. Obviously they're Gravitron instances as well. So yeah, fast and cheap. Sydney also gets the same instances for RDS and Aurora. All right, on to containers. If I just find my notes, yeah. Right, ECS now provides action logs for deployment and orchestration. So basically, you can get logging for your ECS actions. Service Connect now supports zone-aware routing. So what that is, it will try and use endpoints within the AZ that the ECS instance is running from. So minimize cross AZ data charges there. And ECS now supporting private link for cluster endpoints. Machine learning, we've got a few things there. Lambda console now provides a one-click setup for coding agents. So it helps configure your coding agents with serverless skills and serverless MCP. That's sort of taken from the new agent toolkit setup. Bedrock Agent Core now delivers unified observability, so traces and logs into the same CloudWatch log space, or log groups. There's a new AWS Bench, which, as the name suggests, it's an open source benchmarking tool for AWS for AI agents running on AWS. Opus 5 is now available. That's for your Bedrock and Claude on AWS. And the Security Hub MCP app, so gives you Security Hub access through MCP on your desktop. The notes were saying that at the moment it's only the Claude desktop. So yeah, we'll have to see if that comes out to more. It's in preview at the moment, but yeah, I'm sort of interested in checking that one out and seeing how that goes. Networking. So again, this is sort of, there are a few things that are coming up that are like, didn't they already have that? But yeah, so this one now supports listener rules for custom traffic routing. So if you've got a load balancer with IPv4 and IPv6, that gets sends the traffic out to separate listeners. So your IPv6 traffic will go out to an IPv6 listener and IPv6 targets, and similar with the IPv4. So if you've got a dual stack one, you can send them out to the appropriate place rather than sort of having to separate out with separate load balancers. So that's nice. Lambda announcing self-managed code storage. So basically it will chuck your code into your, if you've got your code in your own S3 bucket, it'll pull that straight from there without sort of doing an intermediary step. Cognito supports importing users with password hashes. So previously, if you dumped your CSV file with just users, couldn't do their passwords as well, and they'd have to set them up. Now you can have your password hash in the file that you dump them, so their passwords are already hashed in. And then some pricing plans for SES, some Lambda Durable Execution SDK for .NET now available. If you're using SES for your mail, there's a new mail manager console to help you access your mail for the 4 or 5 people that are probably using SES. And now Lambda publishing logs for managed instances, capacity providers. This one's reasonably interesting. CloudFormation and CDK Express mode. Interesting, but also something that you probably only want to use in certain situations, because instead of waiting for resources like CloudFront, which can take a long time to set up, or databases, it'll just assume that it works and move on to the next. Yep, it's your YOLO for your code. So look, if you're doing it in non-prod environments where it doesn't really matter and you just want to, you don't want to wait around for things, yeah, cool. I'm not sure you'd want to necessarily use that one in prod, but yeah, so for your non-prod, your testing, your sandboxes, speeding up significantly could be well worth it. There's a new cost efficiency widget in the your cost management dashboard. Secrets Manager now publishes secret update notifications to EventBridge. So this one's quite nice. And again, it's probably one of those things you thought, like, shouldn't that have already been there by now? But yeah, so if someone makes some changes to Secrets Manager, you can now have triggers off that and like do things. And another, like, didn't it already, do this, or shouldn't it have been doing this for a while now? But application load balancer logs can now go to CloudWatch. All right, some other stuff. Systems Manager now can simplify. Well, first off, it can utilize Azure VMs and hybrid things in your System Manager, so it can manage those. This new update, you can create a cloud connector, which will then automatically deploy the SSM agent into your Azure VMs at scale. So no longer do you have to install the agent and then hook it up to Systems Manager. You can create the connector and then say, go and deploy it to all the things. This one's also a nice one for anyone that's sort of learning AWS. AWS Builder Center now offers free sandbox environments. And so they've got a number of workshops that run in these environments, so you can spin them up, go through a workshop without it costing you anything. It's in their free sandbox environments. So, well, worth having a look at that. Go to Builder Center/workshops, and there's a drop down, and you can select free sandbox. There's a new type of file cache, KNFSD. So this one's open source Apache 2 license solution for deploying a scalable high-speed network file system cache on AWS. So if you need that sort of thing, it's now in preview, and you can have a look at that. Organizations have doubled their RCP quotas. So if you're using that in your orgs, you've now got a lot more RCPs that you can push out. And yeah, automatic credit memo application preferences. So if you're using credit card details within your AWS account, there's some automation around that. And with that, I will now hand over to, I believe, Stephen. Oh, and I should say, Steve Sennett is an AWS hero and works for V2 AI.
There we go. He got it eventually.
I was like,
how long have we been friends for now?
Well, quite some time. I couldn't remember what your new role was. Is it principal?
See, the thing he could have said there is just like, I didn't know if we ever said we were friends, but still. Anyway. No, that's awesome. So my name's Stephen, I'm from V2 AI, and we also have Dale, who's here, as a software engineer from Five9, and also a AWS community builder as well. And so for this one,
oops, sorry, just a second. Share.
Might need to. Yeah.
Oh. Sorry. And
how many texts does it get us to share a screen?
There we go.
Yay!
And just enlarge. Oops. Just a sec.
Oh, that one.
Oh, that one. This is embarrassing.
Yay!
Okay. Awesome. Did you want the mic? You can
All
start.
right, why not? It's not like we've, is this thing on? There we go. Now this thing's on. It's not like we've actually practiced this.
No.
I mean, we did this talk, what, how long ago?
2 months ago.
And we haven't practiced since, have we?
No.
So this could be really fun, right?
It will be entertaining.
Excellent. That's what we want from a community event. Excellent. All right. So yeah, this is a talk that we originally gave at the AWS Summit about 2 and a bit months ago. And so this one's all about some of the things just trying to get infrastructure as code working in the real world. Now, I'll go through this and just ask a couple of questions. How many people here know what infrastructure as code is? Excellent. Good. For anyone who doesn't, don't worry, you're going to know plenty by the end. Now, how many people are using infrastructure as code in their workplace? Yes. Good. Excellent. How many people would say they're using infrastructure as code really, really well and they've already solved it and it's already working perfectly fine? There we go. Excellent. No, that's good, because the thing with this is infrastructure as code is one of those things that sounds really simple, but honestly, it's not as quite simple when we implement it. So from both of us, we want to come back to some of the things that we've both seen. So myself really as a consultant, having worked across all the different orgs, and for Dale working for a platform company where they've actually spent a lot of time on this. So we can see where some of these things come into it. That's the purpose of this talk. Okay. Hey, there's us. Oh, we look good.
I'm not sure whether these QR codes still work, but if they don't, you can either Google our names or come up to us afterwards and we can connect with you, which would be awesome. We love connecting with people.
Excellent. That's one of us. I'm an introvert. Okay, so, but yes, that is us. Now, in terms of this, now, when we talk to a lot of people as consultants, something I hear, particularly in very large organizations, when I talk about infrastructure as code, something very common pops up. And that's that we try doing infra as code, but it's just too hard when we actually want to scale it. Now, there's an interesting thing here. What do we mean by scale? Because, well, infra as code, you add more resources, it's fine. Like you just make one bucket, make 1 million buckets, that's fine. Scale means different things. In this case, when we're talking about scaling, we're talking about scaling across different teams and business units. The way that I might work, if I'm working, for example, mobile app dev team, might be different to a data team. Different platforms and tech stacks. If you're using AWS, Azure, GCP, you have your own on-prem stuff, that's going to be different again. Distributed roles and ownership. Some stuff might be dealt with entirely by one team. Other stuff might be, well, we kind of part that out to the DevOps team. Some might just be, we don't really know who deals with that. Governance and architecture standards. Oh boy, do we love inconsistent governance and architecture standards. And because in very large orgs, we might think, well, you make the rule and say use infrastructure as code on everything, right? Just use infra as code on everything. The architects have spoken, now it's law. Is that all we need to do? No. Yes. No, so that's it, right? Because the scale is where things get tricky. And interestingly, looking at the research, most orgs don't believe that they've actually reached a state of mature automation when it comes to their infrastructure. And I feel like for a lot of people, that's kind of surprising. For a lot of people, it's kind of like, you know, I feel like we're doing terribly, but everyone else is up there, right? Like everyone else is right up there. We just don't quite know. Thing is, most orgs are in that spot. So the first thing there, very important. And also, hey, I should just be able to push once and it works, right? 43% of orgs say that they need to run their infrastructure deployments more than 4 times to get it right. Does that make anyone here feel better? Right? I know it makes me feel better. Oh my God, yes. Now, thing about this, you are not alone, right? Now, of course, this is research, this is numbers on a piece of paper, and of course, Spacelift were the ones who commissioned this, so, you know, we take it with a grain of salt because it's a vendor. But I will say, in my experience across many different orgs of different sizes, different sectors, this is pretty representative, right? So let's talk through some of the different failure modes for this. First one, let's say we roll out our first project here. Now, when we start out our project, there are going to be some choices. Let's say I'm coming in as a consultant. We're going to build something for you, right? All right. And I have Michael right there. I can see Michael right there, so I'm going to poke at him. All right. So I might talk with Michael. He's working in the org. And I have a talk with him about, you know, what kind of tooling choice might we want to use? What kind of infrastructure as code tooling? How do we want to break it out modularly? Because, of course, there's different ways we can structure these, right? Different ways for the repo. We could have a mono repo, poly repo. The way we do our CI/CD, we make those choices and we implement it. Lovely. There comes time for project B. Okay, so I'll come in again and we'll have that conversation again. And maybe it's a little different this time because we're having different conversations. And again, we'll do the same thing. And you know what happens here? because we don't have the reusable patterns, we will reinvent the wheel every time a new team and a new project comes in. But we still have infrastructure as code, right? That's not good because we don't have any interoperability. We can't actually transfer our knowledge. We don't have a damn clue what's going on because we keep changing stuff around. And likewise, something DevOps people love saying is that my work's important because undifferentiated heavy lifting. Has anyone heard that? Like, my work's important because I don't do undifferentiated heavy lifting. Right? A few people, yes. Now, if we need to go through, do all this, figure it out, do all this, figure it out again to scratch, do all this, figure it out again from scratch. I don't know about you. To me, that sounds like a lot of undifferentiated heavy lifting. Yes? And if everything's bespoke, we end up with something kind of crazy like this. Now, if you ask me how I like building, I know what I like, right? If you ask me, like, what do I want to build with? I like my CDK. Oh, yes, I do. I like breaking stuff out by service. GitHub Actions is life. And polyrepo is a lot nicer than trying to fit everything into a monorepo and realizing later, oopsie, we need to break this out later. Cool. Guess what? Next project comes along, we're going to do things differently. We're on Terraform, do it by resource. Maybe we'll use code build because we're doing it on AWS specifically with a monorepo. You suddenly have a lot of complexity increase. On top of this, your platform teams are going to spend more time fighting fires because guess what? It's not just a case of, hey, my CDK pipeline's broken. It's, hey, my random Terraform thing that got built for my one particular thing here is broken because I wanted to do one particular thing and it's not doing that. And lastly, our total cost of ownership goes up by a lot. Because guess what? Now, CDK, open source, cool. Terraform, don't talk about that. All these things here, on their own, are pretty cheap to implement. Do you know what the most expensive part in any part of this is? What's the most expensive part? Hint, it's not on the board. There we go, the person. Exactly, the thing between the keyboard and the chair. Cost goes up dramatically. Now, I'll just say, for DevOps engineers, platform engineers, does this sound about right to what we've experienced? All right? How about you? Does this sound about right to your experiences?
My day-to-day experience.
Exactly, and that's why now, I do believe it's now your turn. Congratulations. See, we know how to do this.
We're all right. No one's died yet, which is good. It's always a sign of success. Okay, so I'm now going to go through the specific process you can take to implement an effective IAC strategy. And so for this example, I'm going to be using Terraform. I'm hoping here people are somewhat familiar with Terraform. Could I hands up if you've used Terraform before? Okay, that's good. I had choices. I chose to go with Terraform thinking that would be the one people are most familiar with. But before we actually get to that stage, I quite like analogies. I think they really help to illustrate a difficult difficult concept. Thank you. Got to get my brain working. They help to simplify it so we can focus on these specific things that we need to do in order to be able to produce an effective strategy. So in this case, I'm going to be using the analogy of building a house. So when we build a house, we need to have bricks, okay? And these bricks I'm going to refer to as infrastructure resources. So you can think about these as basic reusable resources, things like an S3 bucket or an EC2 instance. They are singular resources that you can use time and time again. And just as I said, those are some examples. But we don't just need bricks. When bricks come together, they form. What do they form when bricks come together? You guys should be delivering this. You already know. When bricks come together, when we have a number of these infrastructure resources together in a module, we have what is called an infrastructure module. So these are multiple bricks or multiple infrastructure resources. And because they're in the same module, they share the same life cycle. And that's really, really important. I'll go through that a bit more in detail soon, but that is the key point to know. They have to share the same life cycle. And finally, when our walls come together, we have a house. So in this case, the house is our live deployment. So you can think of the live deployment as the infrastructure resources. So all of these infrastructure modules being deployed together provide you with your infrastructure, the infrastructure basis for your application. And this is written in TerraGrunt. So I'll show you if you haven't used TerraGrunt before, I'll show you an example of that in just a moment. So that there is our house. We have our bricks, our walls, and finally our house. So as engineers, we're looking to be able to use these three resources in order to develop and implement an effective IAC strategy. So here's one such way you could do that. We have our infrastructure resources, and I've got the little icons at the top so you know which specific thing I'm referring to. These are our bricks. As I said, they are individual resources. So our first one, is that hard to see? I don't know if I can zoom in if you can't see. That there is a Terraform resource, and it is building an S3 bucket. And we have another brick. This one here is an AWS instance. So really simple examples. These are my two bricks. I want to build my wall, so I'm going to import them into an infrastructure module, and I'm going to instantiate them. So this here is service A. Not a very original name. I'm just, giving it the name service A. This particular infrastructure module, oh yes. Oh, of course, yes, sorry. Yes, yeah. Yeah, we can, I know it's a little bit hard to see. I could also provide people with the resources at this particular presentation at the end if you wish to go through the details yourself. Okay, awesome, thank you. So those are our two bricks. They are going to be imported into our infrastructure module, our wall. And this wall or this infrastructure module is going to be for service A. So this is, oops, sorry. So there you can see we have imported both of these two bricks into the module, and we have instantiated them. So when I say instantiate them, it means that we have defined the variables. So there you can see for the bucket and for the instance, I am giving the bucket a name, a region, and for the instance, I'm giving it an AMI, and I've decided to leave the instance type as a variable. I'll show you why it is that you may do that in just a moment. But there is a very simple example of an infrastructure module. So, okay. But then because these are reusable, I can also use them for other services. So I have here a different infrastructure module, in this case, service B. And for this module, I'm going to use those two resources again, but of course, because it's a different service, I'm going to give them different values. I'm calling this bucket service B bucket, and I'm going to be deploying it in AP Southeast 1. For the instance, I'm giving it a different instance type, and I'm also using the same instance type variable. So that is one way of being able to reuse these infrastructure resources across multiple services. Now that we have our infrastructure module, our wall, on the left-hand side here, we need to be able to import these modules into the design of our house, into the application infrastructure that we are going to be deploying. So how do we do that? Well, as I said before, our live deployment is written in TerraGrunt, and we simply import all of the modules. So for service A, I'm going to import it using a Terraform block. I reference the source, so the destination where the module resides. And then I have to define any variable that I have not previously specified in the infrastructure module. So as before I said, I decided not to declare the instance type in the infrastructure module. You can do that, but if you do decide to do that, in the live deployment, you then do need to declare it, okay? So every single variable has to be declared either in the infrastructure module or in the live deployment. And so in this case here, can you zoom in a little bit? I've got my assistant here. I found a purpose for him. It's been years I've been looking for a purpose, but he's finally,
On one hand, I have the beard. On the other hand, I have the ability to zoom the mouse. I know,
Yeah.
shocking.
So there you can see, I have the instance type that I didn't declare earlier. I'm now declaring it in my Terra Grunt on the right-hand side there. So very simple example of how you can use these resources. When I decide to deploy the live deployment that you see there on the left-hand side, that will produce both the bucket and the instance that you see. Alrighty, so the next question is, how should we actually design our resources? How should we design our repository to most effectively replicate this particular strategy? And this, I think, is the one thing that people oftentimes get wrong, because they're so eager to start that they don't think strategically about how it is that they should structure their repository to avoid this replication, this replication of code that we spoke about earlier. We want to reduce code, we want to simplify the process, and we want to ensure that those bricks that we're using can be used across all services. We're not simply rewriting the same resource again and again and again. So this here is one such way you can do it. You've got the infra repo. That's going to be the name of my repository. And then I'm going to have 3 sub repositories or sub repos, so you can see. And again, I'm using the icons just to help you remember which each represents. So on the left-hand side, we have infrastructure resources. This is where our bricks are going to reside. And because they're written in Terraform, if you're familiar with Terraform, this is what Terraform structure tends to look like. You have a main, variables, output, and a README file. So each of these bricks or these infrastructure resources will have that same structure. For our infrastructure modules, our wall, we're going to be using services. And so each service, and when I say service, I'm talking about it can either be a specific service or a specific project. It is this one thing that you want to use it's this one element of your application. I tend to think of it in terms of services. You want it to be able to share the same life cycle, okay? So service A represents one component of my application. All the resources for that component are going to be deployed or updated at the same time. They're going to be created and destroyed at the same time. That is what we mean, but when we say they share the same life cycle. So service A is going to have the same structure. It's Terraform, so it's going to have that exact same structure as you have in infrastructure resources, same as service B. And obviously you're going to have more services. Each is going to follow that same structure. And finally, we have live deployment. This is going to be written in Terra Grunt. Can you zoom into that? Thank you. And we're going to have this written according to environment. So the first one is our dev environment. It's written in Terra Grunt, which is what you see here on the left-hand side. We have our services. Now, there are our walls. Each of those are going to have a folder and are going to have a terragrunt.hcl file. And you're going to be able to deploy them individually as you need. But obviously, you don't just have a dev environment. You also have probably a staging environment, a prod environment. You have multiple environments. So for each of those environments, you're also going to follow the same process. And that there is how you should be structuring your repository. Now, some common mistakes that I see people making: not pinning their versions. So I'll give an example. I love examples. Here on the left-hand side, we have one which is 1.0. That is not pinned to a specific version, which can produce different outputs. So we don't want to be doing that. Instead, we want to always ensure that we're specifying which version we're using. To the next slide, thank you. Yeah. And then the next mistake I see is hard coding variables. And I'll give you a more specific example of that in just a moment. But you want to avoid hard coding variables, okay? The reason being that once you hard code them, it makes it harder for you to reuse them, okay? So you always want to ensure that you're using variables, and then when it comes time to deploy, you then specify the values that you want to input for that service. So we've got a bad example and a good example right there for you to see. Another example is massive modules. So a module that has over 20 resources is very difficult to manage. So my rule of thumb is that you should keep it to under 2 screens. People have to review the output, and once it's over 2 screens, it increases the likelihood of there being mistakes in the review process. Makes it harder for people to review. So ideally, you want to keep it under 2 screens. Next one. And finally, not using a tagging strategy. So a tagging strategy means that you're referencing a specific version of your infrastructure module, okay? So your infrastructure module is going to be revised. In time, changes are going to be made to it. To ensure that you have control over what's being deployed, you always want to reference the specific version using tags. And I'll show you an example of that in just a moment. Okay. So tagging strategy, this is the final thing I want to talk about. So again, on the left-hand side here, we have the infrastructure module. This is our wall. And I have made a mistake. I've done one of the cardinal sins I said not to do, which is that I've hard-coded all my values, okay? And that is bad. That's bad for a multitude of reasons, one of which is that if I wanted to deploy this module to multiple environments, I'm going to have issues because, first and foremost, you can't produce multiple buckets with the same name. So, yeah, very simple example. Other examples, issues will arise if you try to take this approach. So I'm going to fix this, and I'm going to use variables. So you can see there I'm using variables. So when I make that change to my infrastructure module, what's going to happen is that I go through the GitOps process. So I open an MR, it gets reviewed, and then you'll see there on the left-hand side, once it gets merged, what that is going to do is it's going to produce a new tag or a new version of the infrastructure module. So in this case, you saw that it was previously 1.21.1. Previously you saw it was version 1.21.0. Now it is version 1.21.1, okay? Because I have merged that change. So it's produced a new tag. I'm going to look at my live deployment on the right-hand side there. You see it has the previous tag. But I have changed, I've made a change to my infrastructure module, which means that I now have to, if I'm going to use the strategy I spoke about previously, I'm now going to update the tag. So it's referring to the new version, the one that contains the variables. But also because I'm now using more variables, and as I said previously, any variables you create, you eventually have to define in your TerraGrunt file. You have to instantiate them before you deploy. That means I then have to define them. So all my variables I have now defined in the TerraGrunt file that you can see there. I then go through that same GitOps process. I open an MR, I get it reviewed and approved. I then deploy to my development environment. So my dev environment is the first place that I should be deploying any new changes to. You always start with your dev environment and you work sequentially. You work from your dev to your staging all the way up to prod. You should never introduce changes to prod directly. You should always go sequentially from dev to prod.
We all do that, right?
So I know that's a lot of information. I know it's a lot of information. Are there any questions before we conclude? Yes. It's not Tuesday. Oh, it's Patch Tuesday. I flew over my head with that one.
Show me the Microsoft admins in the room, right?
Yes. TerraGrunt. So TerraGrunt is a wrapper. And again, I'm probably speaking more to the people that are familiar with Terraform. It's a wrapper that you can use to provide greater flexibility when you deploy. It's nearly always used with Terraform. So if you're someone who is working in platform engineering, you're probably using Terraform. You would also almost certainly be using TerraGrunt as well. I was thinking today, like, should I use CDK or should I use TerraGrunt? It's hard because I like using examples, but it's hard to find the one that everyone, it's the one IAC that everyone's working with. There is no such thing, but I think from my experience in the industry, Terraform is the one that most companies are using. So I chose that for that reason.
So if you are using the Terraform, how easy it is to deploy across multiple cloud platforms, how to do it? For example, you have something, that's the benefit, right? That's why we are using Terraform. Then,
yeah. So, well, the process that I showed you, or the strategy I showed you today, is designed for, it's designed to be deployed across multiple environments, multiple regions, because we want to be able to create resources that can be reused again and again and again. We don't want to be creating lots of resources that we then have to, because we've designed them poorly or because we haven't made them flexible, we then have to reproduce them. That's not the process. Good IAC should be about minimalism. It's about taking a very minimalist approach, and the less code and the more reusability that you can introduce early on when you think strategically about these things, the fewer problems you'll have later on.
And I guess one thing when dealing with multiple cloud providers as well is, if we think back to that concept of a module as well, if we're thinking about the fact maybe we have stuff it's in AWS and in Azure, and in the same location we want to put out something like, let's say, a syslog collector. I don't know why I do that in this day and age, but maybe you do. So for that, we would have some kind of virtual machine, some kind of storage, that kind of stuff. Now, we know with Terraform, you can't just say, create a VM on whatever cloud provider there is. It is a little different. But what we might have is having a service module for, let's say, our syslog collector for AWS, our syslog collector for Azure. And then whenever I need to deploy it, all I need to do is just deploy that service. I just need to deploy that module. I don't need to start thinking about, hang on, this is an Azure VM. I need to think about it differently. When I want to deploy that particular pattern, all I need to do is deploy that particular module. And then all the DevOps providers, like all the DevOps users have to do, is really just define what those modules are. And so then it makes it a lot easier to scale across providers.
Any other questions? Oh, good. Awesome. Thank you.
Thank you very much, guys.
yeah, if you
Yeah, I
bring
think
yours
that
in. Excellent. I think we're going to be getting our next speaker up here in just a moment. Now, where's Mr. Jason gone?
I was going to offer drinks, but we got no extra drinks. Or we do have extra food and drinks, but not tonight.
Okay, so since Jason's left me up here with the microphone, okay. Oh, if you say so.
We'll welcome up our new next speaker, Benaki. Thank you. We'll just, for those online, we'll just take a sec to get set up and I think it was 932. Yep. I'll stop share, and then you should be able to. All right. Thanks. Thank you. Great. Everyone, welcome.
I haven't done this in a long time, but yeah, let's see how it goes. Hi, everyone. So almost all of us here probably have, do I need the mic?
Yeah, I'll get that for you. Check that.
Am I audible?
Yes.
Cool, thanks. Hi, everyone. So almost all of us here at some point in time have done some kind of investigation or troubleshooting on some complex issues, probably in production or some local setup that you are working on. So today I'm going to talk about how the troubleshooting process is evolving in the age of AI. And I'll do that using 3 building blocks. One, I'll use EMR as an example service, which possibly can go wrong and sometimes can be complex to troubleshoot. And I'll use AWS DevOps Agent, which is a fairly recent AWS service. And I'll use that to do a troubleshooting or start an investigation. And I'll use a custom MCP server, which provides specialized skills to the AWS DevOps agent to do troubleshooting on a specific service like EMR. So even though this, I'll be using EMR as an example, this talk is not really about EMR. And the patterns and the processes that I'm going to discuss is actually translatable to any complex setup that you have in which information is scattered around services, people, or teams. And it's quite relatable to any complex setup that you are currently working on. So I'll go through the EMR related stuff pretty fast, and we will get to the meat of the topic and discuss more on that. So Amazon EMR is AWS big data service for running big data engine. Typically that means Spark. It also supports Hive, Trino, and Flink. Typically, you will use EMR for running big data pipelines, large-scale data transformations. So AWS provides you the runtime for that, provisions the infrastructure, scales the infrastructure, and you run your data workloads in that infrastructure. AWS also provides you a way to connect to your other AWS services like S3, IAM, VPC, or any other AWS service that's part of your workload. AWS describes EMR as fully managed or managed, but managed does not mean simple. It simply means that AWS manages the plumbing, and but the fact remains that the plumbing is there, and every single network call that you are making, and every single runtime configuration that you're using, every single storage interaction that you're making, is a place where something can go wrong. And typically, when you say I'm running Spark job on EMR, EMR provides 3 different ways to run it, either EMR on EC2, where you have the maximum control over the cluster. You run your cluster on EC2, or EMR serverless, where most of the infrastructure is abstracted, but you still have to configure the infrastructure based on the workload that you are running, and you still have to do Spark configuration. And EMR on EKS, essentially you run your EMR on a Kubernetes cluster. So you have the added complexity of Kubernetes. And how you troubleshoot an issue depends on which operating environment that you're running on your workload on. Now, one of the frustrating things about EMR is sometimes completely different issues present themselves in exactly the same way. You get a notification that the job failed, but it's not a very clear indication from just the message that what really happened. Was it an executor that ran out of memory? Was it a shuffle spill, which means too much data is moving between your stages? Or was it a permission issue? Or was it an upstream job that failed, which is causing the failure? You essentially don't get much information from the high-level message, and it just gives you a symptom. It doesn't give you the diagnosis, and what you need is actually the diagnosis. Now, how do we do that now? Open a bunch of consoles, go to different places, go to the S3 bucket where the raw logs are stored, go to CloudWatch, or in case of EC2, if you're running EMR on EC2, go to the Spark History Server or Yarn UI. Look for the application ID, look for the specific logs. If you're running Airflow for orchestration, Airflow logs. You look at your code, your configuration. If you're not able to find anything, you probably ask your teammate, or you go to your wiki, look for more information. Essentially, you are looking at multiple different places to arrive at a diagnosis of the issue. And all this is happening within the head of the engineer who is actually doing this investigation. And it depends how soon or how effectively you are able to find the solution. Quite often depends on the skill of the engineer and how much of understanding that engineer has on the various systems that are in play. So what really is missing here, I feel, is a consistent investigation pattern. And that's what AWS DevOps Agent provides us. AWS DevOps Agent is a fairly new service that was released, I think, a few months back. It essentially gets triggered or comes into action whenever an alert is fired. You can invoke it manually as well. What it does is it gathers telemetry, correlates deployment, looks at your code and configuration, and ties all of these findings together in a coherent story and a kind of a hypothesis of what might be the issue, what was the reason the issue was caused, and what is the possible mitigation you can do to fix the issue. So it essentially provides what was missing when we were doing it manually, which is a consistent investigation pattern. Now, typically what happens when a ongoing incident is going on, like typically the on-call engineer is a generalist. He has a good understanding of all the systems in play. He can understand what's going wrong where. But whenever there is a specialist skill required, suppose the investigation, the engineer finds out, okay, there's a networking issue. So you call a networks engineer. If there's a DB related issue, you call a DB engineer. If there's an application issue, you call a particular person who wrote the code or understands the code. So you essentially call a specialist to take care of that specialized investigation. And that's what we exactly simulate when we are integrating a custom MCP server with the DevOps agent. DevOps agents owns the conversation, it leads the investigation, but if needed, It calls a specialized agent which can do a specific task, and it can do it pretty efficiently. Now, you might argue that I can just give AWS DevOps agent all my logs, and it can figure it out yourself. And possibly it can do. And I have done investigation just using AWS DevOps agent of EMR issues, and it does a fairly good job. So the argument can be that why do I need an external MCP server? Imagine this scenario that you are running thousands of data pipeline in your production. You are processing petabytes of data, and you have a huge data engineering team, like 25 engineers. Now, if all the engineers, whenever something goes wrong, are dumping Spark logs in the context, things can really go out of hand pretty fast. So, and Spark logs typically are thousands of lines. So this is what an MCP server provides you. It provides you a controlled capability, which is fast and pretty cheap. This is where Harrier comes into picture. I developed Harrier based on the common issues that I've been facing. I manage EMR clusters on a day-to-day basis, data pipelines on a day-to-day basis. I deal with data engineers and data scientists. I see the issues that they face generally. And yeah, typical scenarios, typical use cases, typical errors that we face. I thought it would be good to codify it so that it makes it easy for investigation for anybody, not just cloud engineers, even for data engineers. So what Harrier does is it's an open source. It's not a product. It's just an example implementation. What it does is reads evidence based on which runtime environment you are running your workload on, either serverless or EC2 or EKS. It identifies the runtime environment, reads evidences, classifies failure, figures out on common failure patterns, classifies them, gives them a severity, gives them a confidence level as to, I'm really sure that this is the problem, and then provides you with a diagnosis of what you should do next. Now, AWS publishes best practices for creating and developing MCP agents, and a couple of rules which I followed while developing and designing this was that never give the agent a shell, and whatever capability Harrier exposes, these are read-only small tools, and it has very specific IAM permissions given to it, which follows the principles of least privilege. And every single API call that Harrier does is logged and is auditable. And the next one is every tool should be used as a chain, like the output of one tool you should be able to use as an input of another tool. And that's really convenient when you are troubleshooting issues with DevOps agent, AWS DevOps agent. So this is how the architecture looks like now. It currently, MCP server, it's a piece of code that has to run somewhere. Currently, it runs on ECS, and it is behind an application load balancer and API gateway. Essentially, you expose an HTTPS endpoint. Internally, Harrier exposes 4 different tools, which provide it capability of investigation, generating a report, and getting the evidence, and optionally create a PR if needed. Now, how do we use this MCP agent? Typically in AWS DevOps agent, you have to register an MCP server, and you have to provide a way to authenticate and authorize DevOps agent to the MCP server. And in this case, I use HTTPS SIG-v4, which is AWS native request signing protocol. And so yeah, essentially an engineer invokes investigation using DevOps agent. And once you have registered and once you have added the tools that this MCP server provides, AWS DevOps agent can use those tools to investigate a EMR failure. Now, how does it do that internally? It's a Python code, uses MCP SDK, and based on the input that you provided, like if EMR is running on EC2, you will provide the EC2 cluster ID or the application ID. And based on those details, it understands what is the runtime environment that you are running your workload on. So if it's EC2 or serverless or EKS, based on that, it switches how it gathers data and how it processes them. So internally, it has a way, first it gathers some generic context, which is common to any scenario. It can be the cluster status or the job status and things like that. And then based on the issues, it collects logs, and it has a kind of a list of common issues that can happen. And based on the findings, it assigns it a confidence score as to, this is the finding of the investigation, and this is the confidence level. And there is a certain logic that it applies to arrive at that score. And yeah, once it has, then it creates a diagnosis of what really happened and what is the issue and how it can be mitigated. And as an output, it gives the diagnosis report to AWS DevOps agent. You can dump it in S3, or optionally create a PR, which actually gives you the code change of mitigating the issue. So one of the things which I think it does really well, and that's again, it depends on how well you design the MCP server, is it simulates how an engineer investigates. Like if I'm investigating a complex issue is just like, investigating a murder mystery. Like you don't believe anything and you suspect everyone. So if you have asked somebody in your team to, hey, can you check that configuration and tell me if it's good? And the team member calls back and say, yeah, everything looks good. I need evidence that it looks good. And unless if I am the owner of that investigation, unless I have seen evidence that this actually looks good, I don't believe that, I cannot take things at face value. So that's exactly what Harrier does. Every single finding that it finds, it provides evidence. And if it can't provide evidence, it says it's inconclusive. It cannot, be sure that it was the issue. And when I say evidence, what does it mean? It typically means a log excerpt or a particular metrics or a particular config which actually caused the issue. And for investigating a typical scenario, you would probably do 10 different things. And you will check the infrastructure, you will check the Spark related configuration, you will check a few other things. And what Harrier does is, if it has not checked anything, or if it has not found conclusive information about anything that is not able to find, it reports that. So I know that if something was not checked, I have a clear view, and it's not that, I just see the error. So how that looks is, if I can quickly show. So this is what I'm talking about. So it provides a visual check tree in which, the investigation, I check the infrastructure related things, I check data related things, I check the Spark runtime, observability, configuration, and whatever was not checked is clearly marked as not checked. And this is how a typical report looks like, based on the error that I find, it provides it a severity. And this is how a particular evidence looks like. From a specific log, what were the lines of log that really, were the reason why the issue occurred. And this is how a typical PR preview looks like. So we'll do a quick, I have a recording of a demo. I'll just play that. So I'm not going through how we run this MCP server. It essentially is running on EC2, which is behind an ALP and API gateway. So that is already done. I'll go through the process of registering the MCP server, using it with AWS DevOps Agent, and then simulating a issue scenario, and then using DevOps Agent, how we investigate that. So, you go to AWS DevOps Agent. Typically, I would use CLI or IAC to do that, but for the sake of demo, it's best to do it in UI. So you go to AWS DevOps Agent, you go to capability providers. You already have different out-of-the-box MCP servers that AWS DevOps Agent supports. You go to the custom MCP server and you register in new server. So essentially, the endpoint URL that you're seeing is what API Gateway exposes. So you use this endpoint URL. And then once you do so, a DevOps Agent provides multiple ways in which you can authenticate and authorize DevOps Agent to the MCP server. So you choose, so for this purpose, we use AWS Zigbee 4. And you provide an IAM role, which AWS DevOps Agent will assume when it connects to the MCP server. That gives it the permissions it needs. So you do that, and you provide the AWS region where the API Gateway is. Since it is behind API Gateway, you get the service name, which is execute API. And you just add it. So once you have registered the MCP server, you have to add the MCP server to an agent space. Agent space, you can think of it as an environment of what all the agent can access, what all accounts or permissions that it has or services it can access. So you can define your agent space like that. So this is one of those agent spaces. And you go to the agent space and you add. And this is the already existing MCP, which I just registered. So you go to that MCP server, you do add, and it shows you the tools that the MCP server exposes. So you add those tools within that agent space. So I've added everything. Now you save. So now, once you do that, once you have registered and added it to an agent space, AWS DevOps Agent can now use the MCP server to do the investigation. So this is how it looks. So now we will simulate a scenario in which something goes wrong. I'm using Airflow. I'm not using MWA. MWA provides a local runner, which you can either run on a system or on an ECS container. So in this case, I'm running it on an ECS container. There is a demo DAG, and I've simulated a scenario in which it fails. So I've already run it, and you can see the DAG has failed. So you can start your investigation here, and you can see the logs. So essentially, this DAG runs this workload on an EMR EC2 cluster, which is running on EC2. And this is the Yarn UI, where you see the application ID, and it has already failed. And so now we will use AWS DevOps Agent to investigate this issue. So as an input, you have to, typically what happens on a day-to-day basis is whenever a job pipeline fails, we already know that since we are from cloud team, we already know what cluster the job is running on. In case production has multiple clusters, you have to know exactly which cluster ID the job failed on and which application ID. So these are the two bare minimum things if you're running EMR on EC2. So that is what we provide to AWS. So you go to the agent space, you open the web UI, and it opens up the AWS DevOps Agent UI, and you provide it a prompt. So some of these prompts are already captured in the documentation as to what format you have to give, but typically you provide the EMR. In case of EMR running on EC2, you provide it the EMR cluster ID and the Yarn application ID, and give it few instructions of what all you are looking for. And I'll be honest, sometimes complex scenarios like jobs like this can take, hours to troubleshoot. Yeah, and Spark logs are really complex, scattered around different places. And somebody who actually knows the entire setup and how EMR works and where the logs are stored can effectively troubleshoot it. So it can get really complex at times. So you give this prompt, and one thing that you have noticed in the prompt is I gave it the information that if there is already a registered tool available, use that instead of using your own investigation. So AWS DevOps Agent goes, so I've forwarded it. So it essentially goes through the tools. It takes about a minute to run this investigation. It takes about a minute for it to identify that it has a tool, specialized tool, and then it invokes it, provides it with the inputs, authenticates and authorizes, and then it provides the root cause, and then it gives that evidence as a timeline as to cluster-related and job-related timeline. And then it provides log evidences as to, what are the specific log lines which say that there was an issue. It provides the investigation tree as to what things were checked, what were skipped, what were good, what were not good. And then it provides a recommended fix. In this case, it was a executor memory issue. It had less memory, so it was out of memory. So it provides specific PR recommendations, and it also gives a readiness as to, is it ready to create a PR? You give another command to it, provide some information related to the GitHub repo and the branch, and then it goes to work and creates an actual PR for you based on the recommendation that it generated. And this again takes another minute. And then it gives that, and you can click that link. And it first gives you a patch plan. And then this is the patch plan. And then it gives the exact change that you need to do to fix the issue. Now, it took a total of 2 to 3 minutes to do that. And as I said, sometimes in complex production scenarios, it can take hours. Sometimes we are not able to figure out things, and we have to, engage AWS support to help us out. So that's how easy it becomes. And as I said, this is just a pattern. Even though I used EMR as an example, you can translate this to any complex setup that you currently have. AWS already has several MCP servers which you can leverage, but if there is a custom setup that you are working on, you can create your own MCP server and integrate it with AWS DevOps Agent. So yeah, this is the key takeaways of the presentation today. DevOps Agent is the operator, provides you the operator experience, and MCP server is the specialist that provides the specialized domain capability, and EMR is just an example, and you can swap that to any complex setup that you are currently using. That's all I had. If you would like to add me to LinkedIn, this is my link. Thanks, everyone.
Great. Thank you so much. All right. Does anyone have any questions? All right. I will bring the mic round. So anyone that's on the stream can hear.
So this Harrier stuff, it more looks like a unit test, really, isn't it?
Yes. There's a set of tests.
So how do you deal with cost of tokens?
Yeah. So specific to Harrier. So Harrier essentially does not use any LLM or any agent. It has an option of connecting to an agent, okay. But what Harrier does is it has a standard set of errors that EMR has. So over the years, whatever experience that I have, like related to infrastructure or Spark configuration, so it has list of say 20 scenarios.
So using a local LLM?
No, I'm not using any LLM. So it has a list of errors and a list of scenarios that can go wrong. And based on the log findings, it can arrive at that. So there can be a scenario in which you get an EMR error, which Harrier does not capture at this point in time. But I also has an option in which you can enable in those kind of scenarios, a fallback to connect to AWS Bedrock. And based on the findings, like your common, say, cluster-related things and the log that you gathered, based on those findings, it still is a bounded tool, which is, so it just doesn't go and fetch more logs. It all, yep.
Sorry, basically just using MCP for transferring data.
What was that?
MCP for transferring data.
Yeah, you can say that.
Yeah. So like the DevOps agent has the smarts, and the MCP has the specialist knowledge. So, yeah.
Yeah, I think in your presentation you talked about custom MCP.
Yes.
So, I mean, I'm trying to understand that already in DevOps there is an agent, DevOps agents,
Yes.
which can do all the work. Then
Yes.
what's custom MCP?
Yes.
And if at all, if you're talking about custom MCP, what's the criteria we are putting in there to, I mean, why it's needed and what sort
Yes,
of thought process someone should have?
Yes.
Someone has to do that.
Yes, exactly. And I covered that in one of the slides, is that why exactly do we need AWS DevOps agent can do it. So why MCP server is how you present that scenario. As I said, AWS DevOps agent probably will not give you a standard answer all the time. And as I said, you will burn tokens. If you are running thousands of data pipelines in production and you are petabytes of data and you have a 25-member data engineering team and everybody is using AWS DevOps agent, you'll be burning tokens like anything. So how do you deal with that? So that's what the MCP server provides you. It provides you a bounded tool in which it already has the logic. It's not burning any tokens. It's not using any tokens. It's just calling a tool or the tool that MCP exposes, and using internal knowledge, it knows where to find out the logs, what to look for, and it already has a database of issues. So it's providing you that consistent investigation pattern, which AWS DevOps agent will, you can say, invent every time you provide a scenario to investigate. So AWS DevOps agent just acts as a generalist on-call engineer. Like if you have to use the output of Harrier to create a report or something, that AWS DevOps agent will do that. So yeah, that's why you need a custom MCP server.
Great, thanks.
All right, and we have a question from the YouTube chat. How do you benchmark how well the DevOps agent performs on diagnosing issues?
Yeah, that's a good one. So specific to Harrier, and I cannot convincingly say that for DevOps agent, but specifically for Harrier, Harrier has an internal confidence engine, like based on the evidences it is finding and based on the data that it is processing, it has an engine that that gives it a confidence score. As in, like, I'll give you an example. Like for an out of memory issue, there are 5 things that Harrier checks. It checks the state of the executor, and it checks if there were retries, it checks garbage collection related things. And if all of these conclusively point that, okay, they were retries and the garbage collection was working over time, and if there were exit codes that were related to out of memory, it gives a better confidence. So that is internally built in Harrier. From the perspective of AWS DevOps agent, yeah, I don't think right now you can benchmark it. It would be as good as, is it really working? But Harrier, Harrier is built in such a way that if it is not confident, it says that, yeah, it's inconclusive data. I cannot say. So you have to do more investigation.
Awesome. Any other questions? All right. If not, please put your hands together again and thank Pinaki.
Very much.
All right. And I will shortly come back around for the next part.
Thanks, everyone.
All right. The next part and almost final is the marketplace. Is there anyone that's looking at hiring at the moment? Yep. All right. We have Dan.
Hi. Hi everyone, I'm Daniel. I'm from NAB. I run the NAB Star Camp intern program, which is for technology interns. We are currently doing the application process. It closes on the 8th of August. So it's a 10-week program. You work with me. There's 20 interns. You work with me for 10 weeks. And then at the end of the program, you enter the NAB graduate program as a technology stream graduate. So if you are interested, applications are open until the 8th of August.
All right. Thanks, Dan. And Dale.
Yes, so my name's Dale. I'm a platform engineer who works for Five9, and we are currently hiring for some engineers. I specifically, if you know Java, that would be very advantageous. Go on to the website. If you find any role that you would like to apply for, just message me and I can refer you. Yeah, that's it.
What is that website?
I think it's five9.com.
5 words, F-I-V-E.
Yes, it's 5 FIVE 9. I have to think about spelling there. That's a worry.
Right. Anyone else? Yep. All right. And from our sponsor, Sivo.
Thank you, Jason. So I'm from Sivo. My name is Gokul. We are looking for senior AI engineers. If you are looking for a change, reach out to one of us. We can put forward your and data scientists as well. Thank you, May.
All right. Thank you. Anyone else? All right. Well, we'll just wrap up and again thank our sponsors, Mentel, Sivo, and NAB. Without them, we would struggle putting on these events. So thank you very much to all of them. And our next meetup is Wednesday, the 26th of August. So if you enjoyed this one, we would love to see you there. If you can't make it in person, we are streaming on YouTube. So thank you very much all.